Hi, welcome you all to this channel. Now in this video, we are going to see the importance and applications of digital root and also how to calculate digital root in the topic called numbers. First, let us understand what is meant by digital root. The digital root is nothing else but the seed number. So how do we calculate it arithmetically? Calculation tells you that digital root is the sum of all the digits of any given number. Or I can also say we can replace 9 with 0. That is, for example, if you have a number and if you have 9 in that particular number, you can replace 9 with 0 and count all the other digits. Add all the other digits, and that is going to be the digital root of that number. Or I can also say that I can cast away 9 and add all the remaining digits, or cast away the numbers that adds up to 9 and add the remaining digits, and that is going to give me the digital root of that particular number. Here is an example with three methods involved. So method 1 says it is the sum of the digits as in the previous slide. So I have taken 789 for an example. So digital root is the sum of the digits, which is just 7 plus 8 plus 9, and that's going to give me 24. So again I'll add 2 plus 4 and I'll tell the digital root as 6. So the digital root always has to be a single digit number because that's the seed number. So how do I do it with replacing 9 with 0? So here in the place of 9, I'll take 0. So 7 plus 8 is going to give me 15, but 15 is not my digital root. Again, I add 1 plus 5 and my answer is 6. So ultimately 6 is my digital root as in the previous case. Now the third method is that casting away 9. So I'll remove 9 here because 0 doesn't get any value. So I'll remove 9 here. Again 7 plus 8, that counts to 15. So 1 plus 5 is 6. So finally my digital root is 6. So out of all the three methods, the digital root of 789 is 6 for sure. But which is the away 9? So the easiest method is casting away 9. So you take away 9, also take away the numbers that adds up to 9, add the remaining digits to get the digital root of that particular number. Let's go for examples. So here the first example is 9340. So I'm going to cast away 9. The remaining digits are just 340. So 3 plus 4 is 7. So I tend to say that the digital root of 39340 is 7. Let's come to the next example. 4 plus 5 counts to 9. So I'll take away that. 1 plus 8 also counts to 9. I'll take away that as well. And the remaining digit is only 7. So 7 is the digital root of 18,745. Let's take the next example. So I have 9 here. I can take away 9 directly. 7 plus 2 also counts to 9. So I'm taking that as well. 4 plus 8 is 12. I don't take 12 as my digital root. So as I told you earlier, 12 that counts to 1 plus 3 and 1 plus 2 and 3 is the digital root of that number. So I cannot have 12 as the digital root. The digital root has to be a single digit number. So 1 plus 2, 3 is the digital root of 47,892. Okay, so then the next example is this 836277. So let me take the digital root of this. I can take away 6 plus 3 which counts to 9, 2 plus 7 that counts to 9 as well. Now I'm left with is only 8 and 7. So 8 plus 7 is 15. So again I don't say 15 as the digital root. I would say 1 plus 5, 6, and that is the digital root of this number. Now let us see the applications of. See, generally questions like this will not be allowed to use calculators, especially when it comes to the competitive exams. And to solve this question, you need not actually go for the arithmetic operation, add, subtract, and then take the answer. But still, we can easily find out with the help of digital root. Let's see how is it possible. So before I go to the question, let me first focus on the answer choices and try to calculate the digital root of each and every choice. So to calculate the digital root of every choice, I'm coming over to the first choice. I'll take away 9, casting away 9. The remaining numbers are 5 plus 3, 8. 8 plus 3 is 11. So 1 plus 1 is 2. So the digital root of first option is 2. Let me calculate the digital root of the next option. 5 plus 3 is 8. Again 5 plus 3 is 8. 8 and 8 is 16. 1 plus 6 is 7. So the digital root of option B is 7. Coming over to the third option, I can cast away 9. Then 5 plus 4 also counts to 9. So the remaining number is just 8. So the digital root of option C is 8. So I have calculated all the digital root of the answer options. Now let me go to the question. Again, try to calculate the digital root of each and every number here. So 9 you can take off, 8 plus 2 is 10, 10 plus 8 is 18, 1 plus 8 is 9. So since I have minus here, I'll go with minus. 6 plus 2 is 8, 8 plus 5 is 13, 13 plus 6 is 19, again 1 plus 9 is 10 and 1 plus 0 is 1. So 9 minus 1. Now 5 and 4 that counts to 9, 4 plus 4 is 8, so plus 8. Since it is the addition in between these two numbers, I have taken addition here also. Again this is plus, so I'll take plus as well. 9 you can remove, then check and see which counts to 9 here. 3 plus 2 is 5, 5 plus 4 is again 9. So 9, in the place of 9, I'm going to place 0. So 9 minus 1 is 8, 8 plus 8 is 16. So the digital root is not 16 but 1 plus 6 as 7. So since this equation has 7 as the digital root, the answer option also should have 7 as the digital root, and with no doubt option B, which is 5335, is going to be the answer choice for this question. So without actually calculating, without actually adding, subtracting, we've got the answer. So if you are familiar with digital roots, you can easily solve this in less than 3 seconds. Let me go to the next example. So here is where the example is 15,847 plus 2489 minus 8,999 will be equal to some number. So we can just replace this question mark with x, minus 9183 plus 3942. Again, we are not going to solve this we are not going to actually solve this, but only with the help of digital root. Let's try to calculate the digital root of the answer options. So 7 plus 2 counts to 9, 5 plus 3 is 8, 8 plus 1 is 9. So ultimately the digital root is 9. So 4 plus 5 is 9, this also is 9, and the digital root is 3 here. 1 plus 2, 3 here. So here on calculating, 4 plus 5 counts to 9, 8 plus 1 counts to 9 as well. So the remaining number is just 7. So let's go to the question. 1 plus 5 is 6. 6 plus 4 is 10. 10 plus 8 is 18. 18 plus 7 is 25. So 2 plus 5 is 7. So I have 7 here plus. 2 plus 4 is 6. 6 plus 8 is 14. 14 plus 9 I can anyways remove. So 14 I have. 1 plus 4 is 5. So 7 plus 5 minus, so 9, all the 3 9s I'm going to remove, so minus 8 will be equal to, x is already here, minus 9 I'm going to remove, 1 plus 8 counts to 9, and this is 3 plus, so 9 I'm going to remove, 3 plus 4 is 7, 7 plus 2 is again 9, so the digital root is 0 here. Let's calculate this equation. So 7 plus 5 is going to give me 12, 12 minus 8 is 4, so 4 will be equal to x minus 3. So on solving this, x will be equal to 4 plus 3, which is 7. So whichever answer option has 7 as its digital root will be the number that replaces x. So with no doubt, option C is the answer. Moving over to the question. So here we have percentages. So also the answer options are in decimals. So obviously without using digital root, if you are going to literally calculate, it would for sure going to take at least 7 to 10 minutes of your time. So in order to avoid that and break your time, you can solve using your digital roots. So again, you can solve it in less than 3 seconds. So let's again try to calculate the digital root of all the answer options. So 9 I can while away. So 5 plus, 2 plus 5 is 7. 7 plus 8 is 15. 15 plus 5 is 20. So 2 plus 0 is 2. So the digital root is 2 here. Now 9 and 9 I'll take off. 6 plus 3 also counts to 9, and the digital root of the answer option B is 8. So here coming over to the next last option, 9 I'm casting away. 2 plus 3 is 5. 5 plus 5 is 10. So 10 plus 8 is 18. 1 plus 8 is 9. So again it is 0. So the digital root of the last option is 0. I repeat, 9 I took off. 2 plus 3 is 5, 5 plus 5 is 10, 10 plus 8 is 18, so 1 plus 8 is 9. So in the place of 9, I am replacing it with 0. So let's calculate the digital root of the numbers in the question. So this I am going to write as 189%. So by 100 of. So as you all know, in the place of we generally multiply. Of 682 minus 203 percentage. So again 203 by 100 of 180. So let's calculate the digital root of every number. So 9, I'll while off 1 plus 8, again I can cast it out. So this is 0. So 0 by 1 in the place of 100, 1 plus 0 is 1 into, okay, into 682. So 6 plus 8 is 14, 14 plus 2 is 16. So 1 plus 6 is 7. Okay, so since this is minus, so I'll take minus. So again 2 plus 3, 5, 5 by 1 into 1 plus 8 is 9. So in the place of 9, I'll take 0. So now this counts to 0 into 7 as 0, 5 into 0 as 0. So 0 minus 0 is 0. So obviously, since the question has the digital root 0, the answer option should also have the digital root 0. So with no doubt again, answer option C will be your choice. So when you solve it, it would definitely take less than 3 or 4 seconds and you can easily get the answer. What is the question for you? 89% of 127 plus 158% of 752. I want you all to calculate this and not only the answer but take a stopwatch and also try to find out the number of seconds that you are taking to solve and please post it in the comment box. Thank you for watching.